Now, what does glucagon do? The functions of glucagon are primarily to break down glycogen. So there's a lot of glycogen stored in places like the liver, and this is one of the stimuli to have it break down. It's done by activating the enzymes which break down glycogen and inhibiting the enzymes that form new glycogen. The last thing that it does is it stimulates the enzymes which make the final breakdown product going from glucose 6-phosphate to glucose. Then the glucose is transported out of the cell by a GLUT2 transporter. Now that is the process of breaking down glycogen, releasing glycogen out into the circulation. So this should remind you of the process of we're not building things here with glucagon, we're breaking down glycogen so we can use that blood glucose. What else does it stimulate? The enzymes associated with gluconeogenesis. So gluconeogenesis is the process of making new glucose out of things that weren't glucose to start with, like an amino acid. It also stimulates the enzymes associated with lipolysis. So there you have fat. You can break it down into its more simple form and release free fatty acids into the circulation. And finally, it stimulates ketogenesis, which is the formation of ketone bodies. So between all four of these processes, you should think of, okay, we're breaking down glycogen so that we can get more blood glucose. We're making new blood glucose. We're breaking down fats so the free fatty acids are in the circulation, and we're forming ketone bodies. All of those can be used as energy substrates for different tissues of the body. So glucagon is really preparing you to make sure you can use energy that's been stored in the body so that you can use it for increasing metabolism. So let's now look at this in more of a systemic effect. The systemic view always lets us take a step back, point to the various tissues, see where the different molecules are going. And as you're studying for your tests, this is a very important thing to do. It's easy to get lost in the leaves of a tree without taking a step back to look at the branches and how the shape is. So that is this kind of a process. So we know we have the release of blood glucose. Usually comes from the liver by breaking down glycogen through a number of steps and then finally releasing blood glucose. Fatty acids are also broken down through lipolysis and moved out of adipose tissue into the circulation. Those fatty acids are also form the basis or backdrop for keto acids. So here we got increases in glucose, fatty acids, and keto acids, all to help us do what? Increase our metabolism, because we're responding to some sort of stressful environment.